Most of the region's energy and environmental systems are now located close to the populations they serve. This is made possible through the miniaturization and integration of these technologies and their co-location in residential neighborhoods at the Resource Management Center, or RMC. From the exterior, the RMC appears to be little more than an attractive two-story civic building. But on the interior, an impressive array of technology generates, stores, and controls the flow of the neighborhood's energy and receives, reclaims, and recycles its water and solid materials. As we approach the RMC, we notice the expansive array of solar, photovoltaic, and thermal panels that shade the building's elevation. They are producing both energy and hot water for the surrounding community, while they cool the building's interior. We also notice a rooftop plaza capped by a curious antenna. What appears to be moving just above the plaza are rotor blades of a highly efficient wind turbine, converting the coastal airflow into energy. What appeared to be a two-story structure from the exterior is now clearly an expansive four-story structure, with two below-grade floors now visible. Before descending further, we see the neighborhood's PMV fleet operations and maintenance center. Here the PMVs are refueled with hydrogen, produced by the wastewater treatment facility below. The PMVs also share their electrical energy with the RMC's battery banks and serve as mobile sources of electricity for remote activities outside of the neighborhood's electrical microgrid. Private companies maintain showrooms on the PMV level, enabling neighborhood residents to choose from among a variety of models and amenities available to customize their annual PMV leasing programs. And sophisticated computer systems are housed here that manage both the PMV system and the two-way flow of energy between the RMC and its residential and commercial users, and the region beyond. At the ground floor level, we see an extensive bank of hydrogen fuel cells. Along with renewable technologies, these fuel cells are the combined cooling, heating, and electricity generation source for the neighborhood. These cells are electrochemical devices that directly convert hydrogen or hydrogen-rich fuels into electricity without combustion. Although they resemble batteries, fuel cells never need recharging or replacing and can consistently produce electricity as long as they are supplied with hydrogen and oxygen. This process is much more efficient than traditional thermal power plants, converting up to 80% of the chemical energy in the fuel into electricity. Heat from the fuel cells is collected and sent a story below to aid in the drying and vitrification of sanitary solids. The heat is also used to chill water for district cooling uses in the neighborhood. Sanitary water flows from the community are received at the RMC through separate gray and dark water intake pipes. Utilizing an electrical current from the RMC's solar photovoltaic system, the gray water flows are electrolyzed to produce hydrogen and oxygen for the fuel cells. Dark water flows are sent to an anaerobic decomposition chamber, where bacterial processes produce both hydrogen and methane. Some of this methane is reformed to produce additional hydrogen, while the balance is burned in a glass furnace that turns the remaining sanitary solids into a molten hot material. This material is then quenched in cold water to produce a fine glass aggregate for use in the production of building materials. Recycling of sanitary solids in this manner proves to be far more sustainable than the use of these solids as an agricultural fertilizer, which only recycles trace metals and salts back into the food chain. All remaining waters from this system are then blended and purified with the other major water supply in this particular metropolitan region. At the lowest level, salt water reaches the RMC through a network of inland distribution centers fed by coastal pumping stations and powered by inline micro-hydro turbines. The salt water is sent through an energy-efficient capacitive deionization filtration system utilizing membrane-based seawater treatment technologies. The output is potable drinking water, as well as solid blocks of salt. The water is fed back to homes and businesses through a network of underground pipes, while the salt is sent to regional collection centers for use in a wide variety of industrial processes and commercial products. Essentially, all waters in the region are now recycled for multiple uses. Home, as always, is where the heart is. It's also where the heart of energy efficiency is, now a priority for its occupants. Spurred on by the advances in the miniaturization of energy technologies, their integration in building materials, and sustainable design practices, many buildings now produce as much or more energy than they consume. Siting of buildings for optimal solar orientation, rooftop wind scoops, and vegetation, and automated clerestory windows all take full advantage of natural light, precipitation, and airflows to illuminate and cool the interior. Solar photovoltaic wall paints and glass surfaces generate energy, while rooftop solar thermal units heat water for multiple domestic uses. Many exterior glass walls feature electronically triggered coatings that allow residents to modify opacity at will, enabling the instant placement or removal of windows of any size. Modular interior walls are mobile, allowing for the rapid reconfiguration of space to suit any function. Furniture, internal decorative materials, and floor surfaces are comprised of recyclable materials such as wood, plant fibers, and resins. Most durable goods are now leased, and manufacturers' take-back and recycling programs have resulted in the practical elimination of all solid waste. Bypiping and separation of water flows from kitchen and bathroom appliances also ensures the continuous reclamation of this precious natural resource.